Okay, so before the break, we were looking at first looks at Blender. Some of you all may have seen 3D modeling before. Some of you all may not have, so it went kind of quick. It does take practice. It's gonna be lots of lab time tonight because that's something that takes practice. And I just kind of went through the steps of building a house. Think of connect the dots. We have vertexes, points in space. We move those points around to where we want them, and the computer will connect the dots until we get the shape we want, and then we can add a color and material on it. One thing I'd like to say about Blender, just in the software development thing, because I think most of the people in here are in software development degrees, right? And when you write code, Blender was written entirely in Python. It's open source, it's written in Python. You can add your own buttons to it. Come over to the scripting tab, write new instructions and put them in there. And if you add nice ones, you can they'll add it to it. That's where all this stuff has come. That's why there's so much here, because it became popular and Python is really easy to use. So over the years, lots of people have added more and more and more buttons that work really well. And when the Blender Corporation likes them, they're like, ooh, we'll add this button to the next release. It's two really nice things about software development in general that Blender does. So for one, those who've had me in class before, at least, one of those points I mentioned earlier about things that I was unhappy with in all of my software development classes is one of the things it never once in my class mentioned what to do afterwards. We spent all our time writing code, and then afterwards I had to figure out what was needed to make an installer and put the icons and all that stuff on my own. And it ended up being way harder than it needed to be. Those who've had me in class before probably seen me make an installer, and we can do it in like 20 minutes once we know what the parts are. But I had to do that all on my own with no hints or anything, just having used software before. So that was way up the list of things that I was like, this should be included in the classes. They did a really nice thing here. If we go to where Blender's installed, I think it's under program files. Nope, I don't see Blender. Oh, Blender Foundation, there it is. Got Blender 3.1 now. I have a bunch of files here. And I know Mark has seen this because I've been pressing this issue in our homework classes in the SDEV 220 class with Python right now, is setting up the manifest. So that when we install something, such as, write a program in Python, like Blender here, and then install that on somebody's computer, we want to make sure their version of Blender has it. So we include all the libraries we use and all that. Well, Blender did it a little bit differently. They did that at first, but then eventually they were like, well, this is getting complicated, so let's just install our version of Python with it. So instead of keeping track of all the libraries and stuff they used, they just did a compile of their installation of Python and did their own Python installer. That way they didn't have to worry about whether it was there or not. They just went ahead and included their customized installation of Python along with a Python interpreter instead of the standard of creating a manifest and sending that out. Obviously that takes up a lot of space, so that unless you have something that you know is going to be very popular like Blender, that might not be the best option, but that was a good option. And for those who have worked with 3D modeling stuff before, you've probably seen it. It slows down normal computers. I treat hardware as disposable. The software, the data is what matters. So I always use the cheapest computers that I can get at Walmart. I go to Walmart and get the cheapest computer they have at Walmart usually. So I am running Blender on a 3D modeling software on a Zoom call on the cheapest laptop at Walmart right now. That probably sounds a little odd, even if you've never used 3D modeling software before, compared to what you may have heard about 3D modeling software, like Maya, Inventor, Autodesk, those big ones, all the way up to Rhino. These things do get expensive. Rhino's like $50,000 a year. which sounds like a lot, but you get a team of the best programmers in Japan monitoring every step your team of engineers take with Rhino. So those geniuses over in Japan will often realize that the engineers need a button for their CAD simulation before the engineers even get to that point. So that's the big end. That's what like Ford and GM use. But those big softwares, they tend to slow things down. But on a cheap laptop during a Zoom call, that seemed to be running really quick, didn't it? And that's because there's sort of an interesting setup here that is fairly common. It's not uncommon because it buys us back a lot of speed. All these buttons make it look like we're talking about a huge, massive program, right? You see all these buttons, you're probably thinking of tens, 20,000, 100,000 lines of code to get all these buttons written in Python, right? Well, there is, which that should slow down. That should be really slow, right? 100,000 lines of Python, 100,000 lines of our slowest language. That should be a really slow script. But we don't have it all at once. What we have is this interface. All those instructions, the things the buttons call, those are in a relational database. So it's a relational database full of computer code, computer instructions, relational database full of Python code. So when we click our buttons here, it's not hundreds and hundreds of functions in a Python script like you're used to writing. It's a SQL statement. And the click the button runs a SQL statement, which is really quick to go grab that instruction from the database, from a relational database, instead of digging through all the functions and objects and things like we would normally think of all as one thing as a script like you're probably used to working with. That's broken up in pieces. All those objects, functions, random single line instructions, those are in a relational database, and the user interface just runs queries on that database. So the only thing on that back end is a couple lines of Python code when we click the button, which is what makes it so quick. That's one that does not show up in classes and is a fairly common thing. So everybody in here is a software developer. So obviously that takes a long time to put together, a lot longer than we could fit in a classroom, but it tremendously increases our speed. Like we have 3D modeling software this big that will run at speed during a Zoom call on the cheapest laptop from Walmart. So something to keep in mind for software development in general. So now back to our game dev stuff. So I made this little model here. I'm gonna get this model over to our thing. And later, as we look at more examples, we'll be animating our models. They won't just be still things. So we could drag this right into Unity and it'll work. Let me do that first. Unity prefers when we don't do that. But with Blender, it will automatically convert the Blender files. So yeah, that's why I wanted a couple reasons to use Blender, and one of them being that that advantage of speed, because you've probably noticed Unity starts to slow down here. Create a new project. Oh, well, we got a 3D model, so we gotta go to 3D this time. I'm gonna go ahead and put it in the folder for the repository. Those thumbnails are just always in the way. And intro to Blender is the name of this project, because really all we're going to do here on Unity this evening is load it in. And then we're going to break off for lots of lab time so that you can get started with some trial and error while I'm sitting here ready to answer questions. Yeah, that relational database method of writing code, that's very common in websites. That's what WordPress and Wix do. But yeah, hopefully you understand what I was talking about there. Instead of big Python files, we have a big relational database full of Python code, and then an interface that runs SQL queries to grab only the Python code. So then we don't have hundreds of lines of Python code to run. Anytime we go to do something, we're talking less than 100 lines of Python code probably, which makes it seem really, really quick. And yeah, if I was using Maya or Mudbox or some of the other really fancy ones, that would not be done on a Zoom call. That would not be done on the cheapest laptop at Walmart, period. So it is a very, very good thing to know about in software development. All right, so we have a new project. Seen that before. If I go over to where that Blender file saved, which I think I put it in the delete folder. Have I saved that? I haven't saved that yet, have I? Well, that wasn't a very good idea. Let me go save this file. House.blend. And I am going to send you this Blender file directly in an announcement after class so that you can have that to look at and mess with, and maybe start doing some trial and error practice on that as the starting point. But hopefully you kind of want to do that on your own as well. Okay, so now that I've saved that file, probably should have done that a while ago. Once again, we can just grab that and drag it over to Unity, just like we did with our pings. There it is. If there was animations, we would have the animations there and everything, but all we have is the other information. We have the cube that we modified, which in Blender, over here in the top right, notice it says cube. This is where we would rename that stuff. So as things get bigger, it's probably a good idea to rename them as well. Help with organization. Oh, not Unity Hub. I was trying to get back to Unity. There we go. And just like we did with the other one, we drag it in. There's our 3D model. Unity is set up to go with Blender. It's that easy. They prefer when we actually do the export ourselves though, and we have a little bit of control over it. So I'm going to do it that way, but drag your Blender file in. Unity will automatically convert it to what it needs. And if I come back over to my regular file explorer, come in here, there's this under assets, you'll see there's the Blender file. So I can go into this version of the file, do some editing, and it updates the one the game engine knows about and everything. I wanted to talk about the exports, so I'm going to delete this. Just delete that. Delete it from up here. Notice, oh, I meant to point this out immediately. When we create a new scene, 3D scene in Unity, we automatically have the camera and the directional light. So we do not need the camera and the light from Unity. 2 lights is a big problem. 2 cameras won't cause it so much of an issue. It's extra processing. But 2 lights becomes a big problem, especially if they're coming from different angles and mess up all our shading and stuff. So make sure it's only your model from Unity. And when you're ready, I usually like to select it. That's not really something we have to do. But go to File and Export, and Unity works with the FBX format. So get your model, make sure you hit save. I kept forgetting to do that, and export to FBX. But when I drug that over to Unity, it automatically converts it to an FBX. What you saw in the File Explorer, it keeps it as a Blender file. So it takes a little longer to build because it doesn't do that conversion to FBX. That way we can still have the Blender editing. But if you're going to keep them separate, the version they want is FBX. So you just export FBX, and then we need to set up some options. What do we want to export? So probably not everything. We're going to export the mesh and any materials that go with it. We don't have any empty objects or cameras. We definitely don't want our cameras or lamps. Your armatures are what will have the animations when we get there, so you'll want that. I'm going to hit the button again because we don't have any of that stuff, so it won't hurt at this point to just have them all selected, or limit it to just the selected objects if you have multiple things. The scale, and this one is the most important one. FBX, what Unity prefers to use, what Unity wants to use for 3D models, has -Z is forward, but we have -Y is forward. I thought +Z was forward. I guess it wouldn't really matter. I was thinking +Z was forward, and obviously we can control that. I'm just going to leave it at the default. We can set the units, the transformations. Most of the defaults are probably okay. Make sure when we get to animations, make sure your armature matches. Deformations, a lot of controls there. But this is the format Unity actually wants. So when we export that, it's probably in the same folder. Yeah, there's the FBX file, and then that is the one that we should really drag into Unity, or right click and import new asset, because we can still see the Blender file. But the FBX file, you'll notice if I look at it, it looks exactly like what happened when we drug that one over there. Unity's used to Blender. They're very, very common. They go together. That'll get us a model in there. And one last thing to finish up. Well, I better hit save here. Save this. I'm going to go back to the other one. Well, I'll leave it here. Personally, I like to do the drag the whole Blender file in. So then that Blender file is in the assets, and we can edit it directly, and it automatically updates. I find that to be very, very useful. But every 4 or 5 releases of Unity, they decide that they want to stop that. So then we have to go into the source code for Unity and change this Boolean from false to true. And the FBX file is the actual addition, but they keep going back. They keep going back and forth because they know people like to do that. Probably want a surface to do that on too. So just real quick, I'm going to save this and do another one before we break off for practice time at this. I'll create a new general Blender file. I'm going to delete all the default stuff. So push W until I get that selection tool I like, which is the freeform selection. Select all those because we definitely don't need a camera or a light. And I'm just going to add a new cube, just like that one I deleted. And to keep the numbers straight, I always like to scale that down to half, 0.5, 0.5, 0.5. So then we have a 1 by 1 by 1 cube. So if we scale that up 10 times, then we know we have a 10 by 10 by 10 cube. The default goes 1 meter each way from the origin. So if we scale that up 10 times, then we have a 20 by 20 by 20 cube. And the numbers get a little off that way. So I like to always just cut it down to half and then start with a 1 by 1 by 1. It makes the math a lot easier for scaling. And then pushing Control A and locking in that new scale gives us a better starting point. So now we have a 1 by 1 by 1 meter, and that's a scale of 1. So if we switch to a scale of 10, then it's a 10 by 10 by 10. Or if our scale is 5 by 3 by 2, it's 5 meters wide, 3 meters tall, and 2 meters long instead of the double that and everything. Because if it started by 2, we couldn't multiply by a whole number and get an odd length. Might be a good reason to put that. So this is some surface. So for quick surfaces, we just need a couple directions. So I'll leave it just 1 meter thick, but maybe 120 by 120 meters. That's a nice big surface. And for quick test images, is kind of what I was looking for at here. We'll do something like we did before. We'll switch to edit mode, and we need some vertexes to work with. So I'm going to right click and subdivide that a bunch. We can type the number or just click and drag and get a bunch of vertexes here. Let's subdivide that 15 times. No, more than that. 30 times. Oh, it's 120. What? There we go. Now there's 1 meter blocks there. That'll kind of work. It gives us a bunch of things, and once again, we could grab those and move them around, but there's another tool here that is really, really useful. So once we have vertexes, there's also this sculpt mode. And sculpt mode is like chisels. It's like clay and chisels. We can add some clay to it. Just come through here and add in wads of clay. We do have to have a bunch of vertexes first, or strips of clay. I guess we have a spot. It's kind of hard to see. I'm adding stuff. Add in little wads of clay and make sort of an uneven surface. Maybe carve some grooves in that. And just very quickly go through with the chisels and stuff and carve in some sort of shape. Let me undo. I just made a bunch of changes, so it's going to take me a minute to get back to the cube. Okay, so now we're back in edit mode. Alternatively, another good option. The chisels are good for that. I just wanted to introduce that because then we can mild up clay and basically work with it like little knives like we would with clay. We can still do it this way. If we switch to the sum selection tool, I'll just select a random number of vertexes. I'll look straight on so I don't get any from the bottom or anything. And grab an area like that. Switch back to the front, grab the move tool and bring those up just a little. Back to the top. Once again, with the selection tool, I'll just sort of grab some random spot and sort of do like a topographical version of a hill. Raise these things up just a little bit until we get to start to get some sort of 3D shape there. And we can do slants and things like that, stretch them out, move the vertexes around the same to get the similar thing, but really we just need some placeholders. So we can just very quickly grab some little shapes. And maybe make like a mountain, bring that up really steep and grab some more of the top of that and keep bringing that up, and almost sort of a random thing just to get a little placeholder area going. That'll work and get us some sort of surface. And then we can do the same thing we did for the materials. Or to object mode. So have it selected. Make sure we're in material view mode. So on the top right, we want the middle circle, or render. If you have a really fast computer, like I think most people in here are gamers, so you got the fancy GPU running, you can go to render and see what the final version would be like and get more refinement on your materials. We'll add in a new material here that is something that matches the ground. Maybe green. Green seems like ground. Dark green, that'll work. Just a placeholder, right? We just need something to start working with while the final version of the art comes in place. That'll work. So I'll save that as some the ground. Save the Blender file. Then I'll do the export FBX again. And Blender and Unity are set up very much to go together, so it's generally the defaults we want. Is there something? Yeah, we'll want to make sure that apply modifiers will matter later. But a lot of settings, so we can export that and then go right over to Unity and import a new asset and bring in that FBX file or the Blender file. It works with it. We saw that, but they prefer when we don't do that. But probably the rest of the semester, I'm going to use the Blender file directly instead of the FBX file. We drag that in. So there's our ground surface and our house surface. There's one slight thing I want to go ahead and do now. These are working models, right? So if we start doing a bunch of game stuff, it would be attached right to these things. And then when the final version of the artwork comes in later, we'd have to redo all that stuff. So usually we don't want to drag our images right into the game like that. I'm going to delete both of those. What we want to do is right click over in the hierarchy and create an empty thing. I'll call this ground. And then the ground sprite, we can drag in and make a child of that. So, whoops. It's a child of it. So all of our logic, the game logic, like if there's not much for the ground, if there's an earthquake we program in, so the ground shakes, that works. We're programming an earthquake so that when our character jumps way high in the air and comes down and punches the ground, it looks like an earthquake, the ground shakes. That's the only thing I can think of the ground quickly. That logic applies to this empty thing. And then this itself is just the ground image. So that when we get the final version of the ground later, all of our logic is still applied to this empty parent and everything. And then the image, the model is like an external asset, so that all we do later is just delete that image and put the updated version of the child image there. And then that logic still applies to that empty thing, and that child graphics model follows the parent object around. So, whoops. So we're going to want to do that. Create it, right click and create an empty one, and then make your model a child of that. So same thing here, create an empty object for a house in this case. And then all of our game logic, the scripts and everything we do for controlling it goes on this empty thing, so that whatever image we have, whether it's the first placeholder or the final version, that just follows it around. So notice in the hierarchy, I'm going to select the parent object. Notice how our axes are different. For now, just a couple layers, just one layer deep, because we want to keep things somewhat simple in class. Obviously, we could carry that on through, and the children of the children of the children of the children would give us more control. But in general, one parent object is good. And then we put everything else is a child of that parent, so that we can replace, so we can disassemble it. So we can treat it one part at a time. And then that parent object that holds all of our logic, that one stays there indefinitely, so that we do things like replace the image, replace the sound effects. But notice when I select the parent object and the house object is still showing us those Blender coordinates. I thought I changed that when I exported it. The positive Y is forward, positive X and Z up, but the parent object has the unity coordinates with Z forward, the X and the Y. And here you can really see the difference between, you'll notice if Blender has the forward going that way, the positive are in a counterclockwise motion, but Unity has positive and a clockwise motion. So it's a different orientation we need to watch out for. So it also helps to adjust for that, because then we deal with the same one over and over again. And if we select the parent and drag it around, that child still follows it, because over here in our transform, notice if I select the image, our position is, well, now it is, our position is 0, 0, 0, but that's relative to the parent. 0, 0, 0 relative, oh wait, that didn't need to be 2. It actually brought all that information in. 0, 0, 0, 2, 0 relative to the parent. So we can move our parent anywhere on here. And there's a good spot. I'll put it over here. Set it out right down by the ground somewhere. And we have, here we have to actually use our tools for panning, rotation, selection. But right click, so we have different controls. So right click does that rotating, left click does the panning, middle does the panning, middle does the panning, and left click does whichever tool we have selected here. So different controls, you'll kind of want to mess around with them, get used to them. And then we can come in and set our house right there on the ground. So as we pan around and look at it from different angles, again, same thing we did in the model, you'll spin that world around and make sure it looks right. But before we can start programming things in 3D, we want to do some stuff in 3D, and there is an art component in our course requirements, the major learning objectives. So we should maybe start practicing working on our own stuff. Looks like we got about 30 minutes left of time. I will be sitting here, and I'm probably not going to do anything after this till I go to bed about 10 o'clock. So if you have any questions, I'll be sitting around, can answer them. Now is a good time to go in there and kind of get started with Unity, try to practice making those models and things. I'm going to send those two images, those two models out in an announcement right now or immediately after class. So you will have those if you want to use those as starting points or reference material. But that gets us our first look at Blender. We'll come back and look at a few things over the semester and see bits and pieces of modeling, tips that I've picked up over the last couple decades. We'll see different versions and it just takes some practice. So I wanted to get started with that soon. Does anybody have any questions about that stuff from this evening? Okay, so I assume the silence means no questions. So we'll break off for this evening, and then on Monday it's content. We're going to talk about storytelling and vectors. So kind of an English and a math class. Game development is a big accumulation of different things. Look at art tonight. Look at English, and something that we would normally see in an English class, but we're not writing paragraphs. We're going to be using those art 3D models to tell a story along with programming. So we need to talk about some storytelling tips and some basic math stuff. We're going to get started into that. So content stuff on Monday. Get some practice with those modeling tools. It'll come in handy, and we'll look at some point next week. We'll look at the 2D modeling stuff, but that goes a lot quicker. Otherwise, I will see you all next week. Have a great weekend. If you have any questions, let me know. I'll be around to help. So stop the recording.